When considering the installation of a 200 amp safety switch in conjunction with a new main lug panel, several factors must be taken into account, particularly regarding coordination and protection. The existing setup involves a 240-volt service entrance cable running 55 feet to an existing 200 amp main panel. The proposed addition includes a 200 amp 2-pole safety switch with 200 amp cartridge fuses and a 50-foot run of flexible metal tubing or rigid conduit using 3/0 copper conductors to connect to the existing 200 amp main panel. One primary concern is coordination, ensuring that protective devices operate in a manner that isolates faults effectively while minimizing disruption to the entire system. The 200 amp safety switch should utilize time delay fuses. These fuses are designed to coordinate with the 200 amp main breaker located in the existing panel. The purpose of this coordination is to ensure that if a fault occurs downstream from the safety switch trips before the main breaker in the existing panel. This selectivity protects the safety switch itself and the conductors running between the safety switch and the main lug panel from excessive overcurrent, while also preventing an unnecessary shutdown of the entire electrical system. A new 200 amp main lug panel can indeed be installed with the safety switch acting as the main disconnect. However, this configuration requires that the safety switch be installed upstream or ahead of the main lug panel. The main lug panel itself must be rated for an amperage equal to or greater than the amperage of the safety switch, in this case 200 amps. This ensures that the panel can safely handle the maximum current that the safety switch is designed to allow. Regarding the choice between flexible metal tubing and rigid conduit, both are acceptable options, but each has its own advantages and disadvantages. Flexible metal tubing is generally easier to install, especially in situations where there are bends, offsets, or other obstructions in the cable path. Its flexibility allows it to be routed around obstacles without needing precise measurements and multiple bends. Rigid conduit, whether it is made of polyvinyl chloride or metal, offers superior physical protection to the conductors. It is more resistant to impact, crushing, and other forms of physical damage. Therefore, if the conduit run is in an area where it is likely to be exposed to physical stress, rigid conduit is generally the preferred choice. To decide between flexible metal tubing and rigid conduit, one must carefully evaluate the physical environment in which the conduit will be installed. Consider the presence of obstacles, the likelihood of physical damage, and the ease of installation. If there are numerous obstacles or tight spaces, flexible metal tubing may be the better option. If physical protection is a primary concern, rigid conduit should be considered. Besides the proposed installation of a safety switch and main lug panel, there are alternative approaches that could be considered. Firstly, installing a new 200 amp main breaker in the existing panel could be an option. This would involve replacing the existing main breaker with a new one of the same amperage. This approach eliminates the need for a separate safety switch, which can reduce both the cost and complexity of the installation. However, it is important to recognize that simply replacing the main breaker does not offer the same level of protection as a safety switch. A safety switch provides a visible means of disconnecting power to the downstream panel, which can be crucial for safety during maintenance or emergency situations. Secondly, installing a 200 amp service disconnect panel could be an option. This approach involves installing a dedicated panel specifically designed to serve as the main disconnect for the new service. This option provides a clear separation between the existing electrical system and the new installation, and it can also provide additional capacity for future expansion. However, installing a service disconnect panel is typically more expensive than the other options. Given the parameters, installing a 200 amp main lug panel with a 200 amp safety switch and running 50 feet of either flexible metal tubing or rigid conduit represents a viable solution. It is essential that the safety switch is equipped with time delay fuses to ensure proper coordination with the existing main breaker. This coordination is crucial for preventing unwanted tripping of the main breaker and ensuring the safety of the electrical system. A detailed assessment of the physical environment will determine whether flexible metal tubing or rigid conduit is the more suitable choice for the conduit run. Consider factors such as the presence of obstacles, the potential for physical damage, and the ease of installation. Furthermore, it is important to comply with all applicable electrical codes and regulations. Local codes may have specific requirements regarding the installation of safety switches, main lug panels, and conduit. Consulting with a qualified electrician is highly recommended to ensure that the installation is performed safely and correctly. A qualified electrician can assess the specific circumstances of the installation and provide guidance on the best approach to take. They can also ensure that the installation meets all applicable codes and regulations. In summary, the key considerations for this installation are coordination, protection, and compliance with electrical codes. Time delay fuses are essential for ensuring proper coordination between the safety switch and the main breaker. Careful selection of conduit type is necessary to provide adequate physical protection, and adherence to all applicable codes and regulations is crucial for ensuring the safety and reliability of the electrical system. The installation of a 200 amp safety switch and main lug panel can be a complex undertaking, but with careful planning and execution, it can provide a safe and reliable solution for expanding the electrical capacity of a building. Remember to always prioritize safety and consult with qualified professionals when working with electricity. The proper selection and installation of electrical components are crucial for preventing electrical hazards and ensuring the long-term performance of the electrical system. Therefore, it is essential to take the time to carefully consider all of the factors involved and to make informed decisions based on sound engineering principles and best practices. It's crucial to understand the nuances of fuse and breaker coordination to prevent nuisance tripping and ensure selective fault clearing. Coordination studies are often performed for larger electrical systems to determine the appropriate fuse and breaker sizes and settings to achieve optimal coordination. These studies involve analyzing the fault current levels at various points in the system and selecting protective devices that will trip in a coordinated manner. The goal is to isolate the fault to the smallest possible section of the system, minimizing disruption and improving overall system reliability. In the context of the proposed installation, the time delay fuses in the safety switch should be selected based on the characteristics of the main breaker in the existing panel. The time current curves of the fuses and breakers should be reviewed to ensure that the fuses will trip before the breaker under fault conditions. This may require consulting with the fuse and breaker manufacturers to obtain the necessary data. In addition to coordination, it is also important to consider the ampacity of the conductors used in the installation. The 3/0 copper conductors must be sized appropriately to carry the 200 amps load. The National Electrical Code, NEC, provides tables that specify the allowable ampacity of conductors based on their size, insulation type, and installation conditions. It is essential to consult these tables to ensure that the conductors are adequately sized for the intended load. Furthermore, the conductors must be protected from overcurrent by the fuses in the safety switch. The fuse size should be selected to protect the conductors from overload in short-circuit conditions. Again, the NEC provides guidance on the proper selection of overcurrent protection devices for conductors. The choice between flexible metal tubing and rigid conduit also has implications for grounding. Flexible metal tubing is generally not recognized as an equipment grounding conductor, so a separate grounding conductor must be installed inside the flexible metal tubing. Rigid metal conduit, on the other hand, can be used as an equipment grounding conductor, provided that it is properly installed and meets the requirements of the NEC. The NEC specifies the requirements for grounding and bonding of electrical systems. Grounding is the process of connecting the electrical system to the earth, which provides a path for fault current to flow back to the source. Bonding is the process of connecting all of the metallic parts of the electrical system together to create a low impedance path for fault current. Proper grounding and bonding are essential for preventing electrical shock hazards and ensuring the safe operation of the electrical system. When installing the safety switch and main lug panel, it is important to follow the manufacturer's instructions carefully. The manufacturer's instructions provide detailed information on the proper installation and operation of the equipment. Failure to follow the manufacturer's instructions can result in improper operation, equipment damage, or even safety hazards. It is also important to use the correct tools and equipment for the job. Electrical work requires specialized tools, such as wire strippers, crimpers, and multimeters. Using the wrong tools can damage the equipment or create safety hazards. A multimeter is an essential tool for electrical work. It can be used to measure voltage, current, and resistance. Before working on any electrical circuit, it is important to use a multimeter to verify that the circuit is de-energized. This will help to prevent electrical shock hazards. Working with electricity can be dangerous, so it is important to take the necessary precautions to protect yourself. Always wear appropriate personal protective equipment, such as safety glasses and gloves. Avoid working in wet or damp conditions. And never work on live electrical circuits. If you are not comfortable working with electricity, it is best to hire a qualified electrician to do the job. A qualified electrician has the knowledge, skills, and experience to perform electrical work safely and correctly. They can also ensure that the installation meets all applicable codes and regulations. Remember, safety should always be the top priority when working with electricity. Taking the necessary precautions can help to prevent accidents and injuries. By following these guidelines, you can safely and effectively install a 200 amp safety switch and main lug panel. Firstly, ensure proper coordination with time delay fuses. Secondly, select the appropriate conduit type based on the environment. And thirdly, adhere to all applicable electrical codes and regulations. Always consult with a qualified electrician if you have any questions or concerns. The installation of a safety switch provides a visible means of disconnecting power. It adds to the safety during maintenance or emergency situations, enhancing the overall electrical system. Considering a 200 amp service disconnect panel offers a dedicated disconnect. This allows for future expansion while keeping the system separate from the existing. Selecting components rated for the intended use ensures reliability and longevity of the electrical system. Installing overcurrent protection devices matched with conductor ampacity adds to the system's safety. Installing grounding and bonding practices compliant with NEC standards minimizes the risk of electrical hazards. Always adhere to manufacturer's instructions during installation for proper operation and safety. Using tools designed for electrical work maintains safety. Electrical safety training and continuous education ensure safe practices. Prioritizing safety can mitigate the risk of electrical accidents and ensure the proper installation. Consulting with local inspectors ensures installations meet the current code regulations. When upgrading electrical services, it's essential to consider the long-term implications for the building. A panel with higher capacity offers potential future flexibility. Considering the potential cost savings from energy-efficient appliances when upgrading an electrical panel helps reduce overall expenses. Upgrading service entrance conductors also ensures proper electrical capacity. In summary, the 200 amp safety switch, main lug panel, time delay fuses, flexible metal tubing or rigid conduit installation is a series of decisions. Each decision should be informed by safety, code compliance, and long-term planning.